Hello, this is Dr. Brown, and this lesson, chapter 7.8, we're going to talk about the phase shift of sinusoidal functions. Sinusoidal functions. And basically we're going to be graphing sines and cosines with different periods and different shifts. We're going to graph sinusoidal functions that look like a sine of omega x minus phi plus b. Also, we will be doing some with a cosine of omega x minus phi. Then we're going to look at data and figure out what sinusoidal function might fit the data. Before we go any further, I'd like to remind you of the concept of horizontal shifts. In particular, suppose we had f of x that had a graph that looked like this. You probably recall that if we have y equal f of x minus h, that the graph would be shifted not to the left, as you might think if it's minus h, but to the right by h h units. So basically, if you see a function f of x and you replace the x with x minus h, the graph will be the same, except it will be shifted by h. And just to add to that, if you have f of x minus h plus k, where k is a constant, the graph will be shifted upward by k. It's called a vertical shift. So just remember that, and I'm sure you had that in college algebra. So we're going to start looking at graphing sinusoidal functions of the form a sine of omega x minus phi plus b. And we will also look at a cosine of omega x minus phi plus b. If you have one cycle of the function a sine of omega x, and if it's a sine wave, remember a sine wave always starts out at 0, increases, goes down to 0, decreases, and comes back and completes one full period. If it's not just sine of x, but sine of omega x, the period, and you need to remember this, will be 2 pi divided by omega for a sine wave and a cosine wave. Now, suppose we change it and graph the function a sine of omega x minus phi. We need to figure out how much it's shifted because we did that, and the amount it's shifted is not phi. What you need to do, and you need to remember to do this, if I give you a function that says a sine of omega x minus phi, factor the omega out of the x. And now you can see that the amount it shifted over is phi divided by omega. So we would take the same function, shift it over by phi of omega, and then draw one period of it. And this would start at phi of omega, phi divided by omega, and end at phi divided by omega plus 2 pi over omega, which is its period. Now, if b is not 0, the function could be raised by the amount b. So now you need to remember these concepts related to a sine wave of any period and any phase shift, that y equals a sine of omega x minus phi, or y equal a cosine of omega x minus phi, with omega more than 0, that the amplitude is always the absolute value of a. The period will be 2 pi over omega, and the phase shift is phi divided by omega. And what I would do, rather than just trying to remember this last one, you do need to remember the period is 2 pi over omega, but once you see a sine of omega x minus phi, write that, factor the omega out, and immediately you'll see what the phase shift is. Now, obviously, a sine wave will look like this, and the amplitude is the absolute value of a. So it will go up to a maximum of plus absolute value of a, and go down to a minus absolute value of a. And the peak to peak value of the sine wave is 2 absolute value of a. In other words, a sine wave will go up to a max, go down to a minimum, and that peak to peak is 2 times absolute value of a. Now, the textbook talks about using what they call key points to graph sinusoidal functions. I believe really that the best way to do it, and to be able to get good insight into what a graph looks like, is to use your calculator and take for instance, a sinusoid, or it could be a cosine usoid, so to speak. And you take the amplitude A and the vertical shift B to determine what Y min and Y max might be, and that you'd want to put into your calculator. The Y max would be the absolute value of A plus B. The Y min would be minus absolute value of A plus B. And you might want to add a little bit to the top and bottom to show some headroom on the graph, but you don't have to. Calculate the period 2 pi of omega and set x min to be minus 2 pi of omega and x max to be 2 pi of omega. Enter it into your calculator, display the graph, and you'll see 2 full periods. Now, if you just wanted to see one period starting from 0, you would put x min equals 0. Here is a fairly simple function. We want to determine the amplitude, the period, and the phase shift. And rather than just remember a formula, go ahead and do this to get the phase shift correct. Factor it 2 out, and then multiply the 2 times what's in parentheses and make sure you factored correctly. And now you see that the amplitude is equal to 3. And the period is equal to 2 pi over 2 equal pi. So we expect a period of pi and a phase shift of pi over 2, which is this number. And it'll be to the right. Now let's just go ahead and put this in our calculator. Put 3 sine of 2x minus pi Notice you don't have to factor it to put it into the calculator. And in this particular case, they're just starting from 0. So let's put x min equals 0, and we'll just see one period. And remember, the period was pi. So let's go 0 to pi. And now, since the amplitude is 3, we want to have a y min of, say, let's go make it minus 4. That's giving it a little room to plus 4. Obviously, the sine wave will not get that high, but it'll give us a little headroom. So graph it, and as you see, we see one period. And this is 0, and this is pi. Now another problem, we have a cosine function. Now remember, a cosine function always has its peak at 0. Now this is going to be shifted, of course. So let's go ahead and write y equal 2 cosine, factor the 4 out, and notice the amplitude is equal to 2. The period is equal to 2 pi over 4, which is pi over 2. And the phase shift is equal to 3 pi over 4. So basically we're going to expect a sine wave or cosine that peaks up at 3 pi over 4. Notice in this case, they have chosen to show more than just a couple of periods, so we'll probably do the same. Let's put in y equals 2 cosine of 4x minus 3 pi, and I believe there's a typo here. We want to subtract 1. Notice we expect that because you can see that things are as a vertical shift downward. So x bin we're going to set at minus pi. X max, let's set at 2 pi. X min equal minus 4. X max equal, let's go with a plus 2. And let's graph the function. And notice that we see what they have here. And here is the cosine function that has a phase shift of 3 pi over 4. Now, we're going to show one example of looking at a sinusoidal function and build a model from the data we see. And we have some data on the temperature that was measured from data over a full year, and they want you to fit a sine function to the data. So, for instance, in January, the average monthly temperature was 30.7, February 32.5. All the way through the year, you see the temperatures going up. Then by December the 12th, it's down to 30. Now you graph it, and notice that it does look sort of sinusoidal, and it looks like the peak is at 74.2, which happens to be July, the 7th month. And we're going to graph this in the month, going from 1 to 12. You can see the minimum is 30, and just looking at it, you could imagine a wave, a cosine wave, that has an average that's right between the peak and the minimum. And looking at this, the amplitude that we want would be the largest value minus the smallest value divided by 2, because the amplitude times 2 is really the peak-to-peak movement of the data. So taking 74.2 minus 30 and dividing it by 2 gives us 22.1, which is the amplitude of the function we want to generate. And this looks like a cosine wave shifted by 7. Okay. So we're going to build a cosine wave shifted by 7, and the vertical shift is going to be the average of the peak and the minimum. So we add it, 74.2 plus 30, divide by 2, and the vertical shift, our B, is going to be 52.1. Now, we know the period is 12. That's 12 months. So 2 pi over omega has to be 12. So solving for 2 pi over omega equal 12, we get 12 omega equal 2 pi. So omega is equal to pi over 6. So now we can just plug this into our formula. Remember, y is equal to the amplitude cosine of omega x minus phi over omega plus b. So plugging in, we get 22.1 for the amplitude, cosine of a pi over 6 times x minus 7 plus 52.1. Now let's see if we plug this in, if it looks like a good model. So I'm going to go ahead and put y equals 22.1. Let's do it just like we have cosine of pi divided by 6 times x minus 7, close parentheses, plus 52.1 and now let's see, we want to start out at x min of 0 and an x max, heck, we could make it 75. It's not going to get higher than that. I'm sorry, x min 0, x max of 12 is the number of months, and then a y min of 0 and a y max of 75. And let's graph it. And sure enough, we get a cosine wave that's shifted over by 7. And if we take the results and then put it next to the data, looks pretty close. Then if we take it and shift it over, we see we have a pretty good fit. You don't always get that great a fit because sometimes the data is not going to be perfectly sinusoidal. But that is the lesson for today.